Oh, that might have been the
I
problem.
will kill myself.
I didn't think about the
Oh,
bounds.
actually stab
That's
myself.
right. Yeah, and then you have to go from there
To approximate what it would be
so
from
like,
because when you
cryptic. Be cryptic.
yeah.
did it take
That's
you guys
it.
a while to get it?
That's an error still.
This one's still loading.
Oh, it's low.
Yeah, that's what would happen with my calculator. You guys plugged it in and it worked?
Well, I don't know what you're talking about.
Yeah, I'm pretty sure.
Oh, you guys you didn't get this at all?
No, that's what I got.
No, I don't remember that. Like, I blacked out.
I'm pretty sure that's what I did.
My calculator was
Joyce,
not
they're talking
good.
about the
I tried
test,
so many different
but
calculators
cryptically
reading on my
because Gerardo's
calculator.
taking it, so then it's all difficult.
Can we go outside and talk about it?
No, we're grading our when you see you thinks, you crazies.
But it's just like, I mean, we did it from last year. I mean, Gerardo's the one that did it.
I know, I was gonna ask if you guys had any questions on it. You
I
don't?
do actually though.
That's what I thought. See?
I don't know. Can I look at my test? Because I'm pretty sure that's what I did.
If you have questions, come ask me after school.
Alright.
Hey, go team.
Alright.
Or during
So,
lunch.
I'm pretty sure that's what I did.
Yeah.
B6 through 9.
Yeah, right? I didn't know why. It looks like you did it, right? I don't know.
And so I just tried a bunch of different ways. And I was like,
Yeah, we can't tell if something's turned on in this calculator. It shouldn't be, or what's changing. I don't know.
I tried like 3 different methods. I'm trying to get the
All right. So, what do you guys have?
can we go B6 through 9? Oh wait.
Now, hold on. Is this like the all in all, like this is the perfect variation of what you should be filling in? No, of course not. Because maybe your way of remembering, like maybe you could be writing down problem-solving procedures. Maybe you could be writing down formulas. Maybe you could be writing down forevers. Maybe you could be writing down hints or tricks that we've done. Maybe you could be referring to specific AP questions. I don't know. But in general, is this stuff right? Yeah. For domain, I'd probably just add in even-powered roots, not square roots. I would probably mention trig, even though technically it's only because of the denominators, like tangent, sine, or cosine, and cosine is 0.
I was trying to figure out for so long how to answer that. I was like, I don't know.
Domain?
What to write. Yeah, for
Yeah,
domain.
But set the argument equal to 0.
You say assume it's all real numbers unless it has this problem, this problem, this problem, this problem. And I wouldn't say non-negative, even though that's true. Square roots, I'd say greater than or equal to 0. Logarithms, I would say greater than 0.
Yeah.
Right? Vertical asymptotes, I'd probably say something like the limit as x approaches a, like vertical asymptote, assuming it's at x equals n. Number, you said number over 0, right? Infinite form would be number over 0, not 0 over 0. 0 over 0 would be a whole. So the limit's infinite. So I'd bring in infinite form here. And otherwise,
Now we're good.
for IVT, I would say in between y value to a number. Is that cool? Letter B?
Oh, yeah, B.
Any questions on those?
Alright, so B4 and 5, I put the same exact thing.
Yeah, I would say degree tests and or L'Hopital's. True. Maybe fleshing out degree tests, but L'Hopital's could work too if you have infinity over infinity, right? So infinity over infinity, you can do L'Hopital's, or you can do
My only
degree
thing
tests.
was, like, with the L'Hopital's, so B4, it said just find the limit as x approaches infinity of x, but then on B6, it said limit, oh no, as x approaches it, never mind.
Hold on. For horizontal asymptotes, put a quick little beware exponential functions. I have some multiple choice sort of by topic, kind of like limits, continuity, differentiability, definition of derivative, mean value here. So we're going to do a few of those today, but one of the ones that the AP loves or has tricked kids on before is horizontal asymptote. They're like, yay, limit to infinity, but they throw an exponential function in. Question, what is 2 to the x as x goes to infinity? What's 2 to the x as x goes to negative infinity? 0, because it's 1 over 2 to the infinity. So depending on whether you're going to positive or negative infinity in horizontal asymptotes, technically you check both. Exponential functions can be really strong if you're going to positive infinity and be the strongest, like the highest degree to test, but they'll be really weak as you go to negative infinity, and even constants would be them. Beware exponential functions. We'll see an example of that in a moment.
Misty,
Yeah.
for B2 and B3, can those be the same thing? technically because
Yes and no. I would just say with piecewise functions, it's good to note that if you do need to do something with a limit and a piecewise, make sure to go both pieces if the inequalities are greater than or less than. And then remind yourself if the inequalities are not equal to and equal to, which one do you plug into for a limit? If the inequalities are greater than less than, we have to plug into both and come from both sides. But if the inequalities are not equal to a and equal to a, how do we take the limit as x approaches a? Do we plug in? We plug into the not equal to.
And then see if it's continuous.
so if I say
Yeah.
the limit as x approaches a negative and then a
Yeah.
positive. Okay,
Yeah.
that's fine. Okay.
Okay, here's B6 through C4. You guys see l'hôpitals? Remember, the AP is going to do la hospitals, right?
Yeah. And I.
Remind yourself you can only use l'hôpitals when it's indeterminate, true? So 0 over 0 or, I would put a little or, infinity over infinity. And then 7, 8, 9 are all saying, try to get it in fraction form. I do like how they're getting specific. Yes, high feature Dorado and hydros. I know you guys knew the original one. I'm just going to scroll down so you can see a little more C. But I'll let you still see 7, 8, 9. Because I'm guessing that's where we got a little stuck, right?
Yeah.
Like it's l'hôpitals, but remember we need the over.
But yeah, I can remember the natural one. I thought it was. But I
Yeah.
wasn't sure, and then
Because you need the
I remember
ln
the
to
DA.
pull down. But it's going to be ln of both sides. Remember you have to solve by taking e at the end. Then on this one we make it a division by 1 over the reciprocal. That one, if you can, do a comment amount. That's usually the answer.
That one you guys were complaining about earlier, was that number 12? 7?
I don't remember.
You mean the weird calculator one?
Yeah, because I'm not getting the answer, period.
It could be. I don't know what one.
oh, was it?
And on these ones, especially for the ones where you're like, it might be good to find an example. I don't have any readily available up today, but for the l'hôpitals, but I definitely need to find you guys good l'hôpital examples. There's plenty in our notes though.
I would be so happy if this year was the year with a lot of l'hôpital.
Yeah, but some of them get hard. It's not bad.
But
And every now and then they throw in one where you think the answer is like 0 and it's e, or is it infinity and it's e? You know, the 1 minus 1 over.
I see for C4, where are they getting H and K?
oh,
Isn't it A
Oh.
and B?
They're saying, well, you're supposed to be finding an approximate of the derivative, but you're being given a table, and you have to say that that x value is in between two other x values, so you're doing the average rate of the points that straddle the point. So they just made up, like, okay, there's an h and an f and h and a k and an f and k, they just made up ways of talking about it.
So that's within, like, it's A to B and then H and K are
Yeah.
Got it.
Well, they do use straddle, look at them.
as well.
I can scroll down.
Yeah.
So let me know if you guys have any questions on what you're seeing, what you're checking, or what you think would have been a better way of putting it. So I definitely agree there are better ways of putting some of these.
Can you repeat why was K again? Can you-
Because A to B is the entire interval of the big chart, the big table. But if they say approximate at x equals c, c is never going to be in the table, or it shouldn't be. There's instead going to be points straddling it, and you use f of b minus f. So they didn't want to use A and B because they were already using A and B, so they just chose H and K.
Or,
Does that make sense?
but I can leave it up to be myself.
Yeah, as long as you realize it's the inner 2 points and not the outer 2 points. Remember, normal means perpendicular. Are there some more C's on the next page? I think there are, right?
Yeah, there are. Well, you have one. This page is. You have. Oh, yeah. We have 12 and 13. We have 10 through 13 on the other side. You have.
Okay. This weekend, I want you guys to do E, D, E, and F. AB has to finish their whole packet, but they also got it a day earlier. So I'm having your whole when you see you think like to turn in or to show me the whole thing by next Wednesday.
E.
Next Wednesday. Remember our Forever Endeavor quest is on Thursday. Make sure you get. Ooh, I need to update. I'll do that this weekend.
EF and then GH.
GHI, and then the last day will just be JK.
Just kidding. Not gonna do it. What? You said it.
Sections J and section K.
I did.
Any questions on what you're seeing, or any comments, or what you think would be better? You guys could add polar and parametric in here if you want, but you guys know what to do. What's C9? That's weird.
C9 approximation value. Oh, that's a approximation for something Asian. I remember that.
Local linear approximation or tangent line approximation. So it sounds weird, but they're saying approximate a y value at an x really close to the point that they've given you. Does that make sense?
Just plug in.
So find the equation of the tangent line, plug in, but what else did they talk about? Over and under approximation, remember?
Yeah.
And we can tell that by concavity. So test the concavity. Concave up means under. You just show a little picture if you want. And concave down, it's going to be an over.
How did they say to approximate? Did they plug in x? So they did a
They
minus
say,
x1?
depending on the concavity. Oh, they say find the equation of the tangent line and then take the new entire x value and plug it in, plug it in. So plug it in this x
So I
spot
plug
after
in-
you make your tangent line.
Do I plug in a or do I plug in x of 1 plus a?
X of 1 plus a.
So then it would just be a.
Because a goes here. No. A goes here. It'd just be x of... A is how far off from x1. So it would end up just being a after you subtract, Georgie. That's true.
Okay.
Unless you've simplified the equation and then you plug in, you won't see all of that happening. But remember, they don't always give you x of 1 plus a. Sometimes they give you like, hey, tangent line at 3 and find the approximation for 3.1. And you're like, okay, I'll plug in 3.1. But anything else you guys are wondering about? Good.
Oh wait, C11.
Sorry, C12, C13, and here's C11.
So f prime of x equals m, and then
They
What
say
does G
and they share the point of tangent C. So they share, so this tangent line and the function share a slope. The slope is the derivative. And then they also say they share a point. So depending on, like if you have this relationship, you could plug in for any y's in this. You could plug this in and solve for x. To find like when this tangent line hits the curve or something. So saying they share the point and the slope is the same as the derivative.
Okay.
Does that make sense?
For 12, I just put like the actual equation from like the forever card inside.
yeah, but
That works. Just remember to plug into the equation. It's 1 over f prime. You take the derivative of the original, but you f inverse of x. To find the f inverse derivative of, say, 2, you need to plug in the y of the inverse to the f prime, not the x. Does that make sense?
Yeah.
So that's why. And I think it this way, that if you're given to find f prime of a derivative, and you're given f in we're trying to find f inverse prime of a. It's 1 over f prime of, if you're given f inverse of a equals b, it's 1 over f prime of f inverse of a, so you're going to plug in b. Does that make sense? They use implicit blah blah blah. I don't like implicit, but that's just me. Is that good? C13 says, how do you think about differentiability of a piecewise? First of all, it must be continuous, so the limit has to exist of the original, and if it's differentiable, the limit has to exist of the derivative. So derive the piecewise function. The limit has to work for continuity like we talked about above, and then the limit has to work also for the derivative itself. Okay. So you guys have your when you see you things. Pass back your old tests. You guys know the old directions. What you're missing is this.
That was my.
Happy birthday.
That was my last part. I was thinking it was like
2016 BC FRQ. What did they see last year?
Yay.
Oh, why did you do that?
Okay, the funnel.
Was this last year's? Yeah.
They don't have the ladder one.
Was there a ladder one?
Last year was
Did I
the
get
last
everyone?
one. Twice? Oh no. Two extras. Try to win.
You never gave me an FRQ.
Oh, I gave it to you on your B. I had 2 extra, I didn't know why.
That was for the last part. But I'm talking about.
Okay.
We do have some AP multiple choice practice that we want to play with. However,
Maybe that was
Here's this.
what sounds scarier, multiple choice or FRQs?
multiple choice.
Oh, stink. We're all over the place.
I like FRQ because you don't have to match.
They're so much harder because you have no way of knowing.
I don't think so. I mean, like, 'cause I thought we knew it pretty well. I don't know.
Did I really?
Oh, was the last one the very easy one? No.
Nope, because it's BC.
Oh my gosh.
Remember, BC has some of the AB ones, but then it has BC ones.
Wait, it had the funnel? That's funny.
Yeah,
Don't they get the same ones as us?
They get some of
Plus.
that.
some. They get at least 3 of the same ones. Some they might get 4. They get 3 or 4. I forget how many of the same ones.
This
Don't we
upsetting
only take
so
6?
much.
There's the Taylor.
And then when
Taylor's
you
BC.
explained it, Miss Dean, we were like, oh, this is so much easier
Really
than we thought.
bad, yeah.
I remember doing it. I was like, yay.
The picture confused you guys, but, like,
like this one in class in BC. I
No,
remember
it's
it.
okay. We still
I
have.
was so excited.
Euler's method. So number
Euler's.
6 was BC, number 4 was BC, and
Number 6
Number-
before.
2 was BC?
Oh my gosh, Misty.
Number 2 was BC. So 3 of them are BC and 3 of them are AB.
I remember 1 and
Freaking kidding me.
So 1 and 2 are calculator, the other ones are not.
Okay.
I remember 1, 3, and 1, 3,
1, 3, and 5 should have been AB, and then 2, 4, and 6 were BC.
and we had some nice things.
Okay, so we have options. I do have some multiple choice that we could play with. However,
Whatever. I'll do
Hey,
multiple
we'll play
choice.
with
we could play with FRQs, which I was hoping for us to be able to grade on Monday. But you guys know how to grade your FRQs. I could just post an answer key online.
It's just the variations.
Let's do multiple choice for like a few minutes. Let's do multiple choice for a few minutes, and then I'll give you guys time to work on 1 and 2, because 1 and 2 are the ones I want you guys to try for Monday.
Okay.
What's special about 1 and 2 on FRQs in an AP exam?
Calculator.
Calculator. So I'm going to give you like the last 10 minutes of class to work on those. But let's just do a few multiple choicey ones. Sound good?
We
Okay.
get 30 minutes per. Okay. No.
15 minutes per problem. 30 minutes for the first 2.
And then 4 divided by 6.
Now, for AB, I have all kinds of examples just because, you know, they're AB. But let's go ahead and have some fun with you guys. Let's start with...
Are we writing this down or should we just scratch paper? Or?
I actually have them doing it in the back of their spirals, but some people had some extra room in their notes, and so they're just doing it. I'm compiling, like, regularly, so I have answers for each. And then they're going to their When You See You Think, and they're writing down certain problems that illustrate certain topics. You guys can make it what you want it. I would put it somewhere organized. So either the back of your spiral or in your comp book and just call it AP Exam Review. I'll have a topic for whatever I'm giving you. And basically until next Saturday, I'm kind of just trying to hit every topic. The FRQs, of course, are mixed, but the multiple choice I'm trying to hit.
Is you'll be using our spiral for note or for homework at all?
No.
Okay, so I can go from the last
Yes.
page.
Yes. All right, so let's just try 1 and 2.
Wait, we didn't turn in our
I'm so dumb. I thought this was the last one.
We
So I
need
did-
to, but Gerardo.
So I didn't do my calculator on this one, then I turned the page and I was like, oh, I'm so dumb. Because this one's the non-calculator.
You can use your calculator now. You have a little extra time. All right, Joyce, I'm going to pause it.
Did you want our spirals and our notebooks at the end of class?
Yeah, leave me your notes and your spirals at the end and pick them up by the end of the day.
Misty, what's the topic of this one?
I'll bring them.
Limits. The topic is limits.
Last night, so I didn't go and get
Number 1, final answer. What'd you guys get? B. Yes, degrees are tied. Number 2, what'd you get?
Hey.
No!
Dang it, I knew it. No,
I told you, you gotta watch out for the exponentially functions. As you go to positive infinity, what wins between the constant and the growing exponential?
It's frozen.
The growing, oh, it's frozen? That's lame. Is that better? It's still frozen. Oh my goodness, stop. Okay. What wins if you're going to positive infinity for an exponential? The exponentials, because they're getting bigger and bigger and bigger and bigger. So the ratio of leading coefficients of those exponentials is -1. But what wins as we go to negative infinity for an exponential? I asked you guys, for exponentials, what happens as you go or you approach negative infinity, and what'd you guys answer? 0. So doesn't this guy go to 0 because it's 1 over 2 to the infinity, and doesn't that guy go to 0? Who wins?
Wait, Misty?
Yep.
This might be like killing some puppies, but so if I have 2 to the negative infinity,
That's 1 over 2 to the infinity.
right? But then I would also have another 2, so I would
Nah, you're killing
2.
kittens.
See, that's what
Look at it.
I
Look
thought
at
I
it.
was
You can't
killing
just randomly class off stuff. You have to factor and then reduce the
Wouldn't they
factors.
flip? So like it would still be 2 to the infinity over 2 to the infinity.
But then you would also multiply it by the 1 down there in the bottom. You have to get a common denominator before you can flip
Oh,
them.
I see what you're saying.
There you go.
Alright.
I tricked you guys. You guys.
And you talked about it.
I know. There are more examples, but you guys should be able to do that. Yeah, this one's good. Ready, set, go. We talked about continuity and differentiability in A, B, and C. Of when you see, you think. So what do you do with the piecewise?
You be wise. Oh.
What's going
You
on?
suck at math.
Okay. Question.
Amsfield.
How do I find the limit?
We gotta do the limit as x approaches to x. Yeah. What's that?
And what do I plug into to find the limit as x approaches 2 for this piecewise with
Bottom.
these
The
inequalities?
bottom one.
No.
Only the top one.
Only the top one.
Oh, only if x equals 2. Yeah.
Okay, question. Could we do some algebraic factoring and then canceling?
Yes.
You can.
But it's in.
But couldn't you also do L'Hopital's and say 0 over 0 and take the derivative of the top, which is 2x, and the derivative of the bottom, which is 1?
So that's 4. That's what I got anyway. But I didn't get
The limit exists. Check. Wait a minute.
But it's not continuous.
Oh, why isn't it continuous?
Because it equals
4
y.
does not.
Okay, sorry. And if it's not continuous, it's not differentiable. All right, fine. I was on a different problem in my head.
Oh.
Los
Oh,
Santos.
okay. I was like, oh my gosh.
Scared me. Scared. Are you guys ready for something else? Let's go do, you guys are good on all those. We got it, right? A, yeah. Continuity differentiability. Topic number 2. Continuity differentiability. That one's too easy.
They're all too easy, Misty. You're not gonna find a hard one.
Like the first one.
Let's just do number 6.
Well,
Okay.
you know.
Ready, set, go.
Does that make it hard? No. See, these are hard. These are really hard.
Ready, set, go.
Isn't that, finding C or like K is like, what the heck, Beelzebub?
Ready, set, go.
I was in Jackie.
Minus C, yeah, but then I got, so C equals 2.
Yes.
Right.
So now you plug into the original.
Right.
2 times 2 plus D
2 times 2 plus D, that's 4 plus D, and then minus 4 minus 4.
equals 4 minus 4. So D equals -4, right?
Yes.
So if you add them together,
That's what I was thinking. That's what I was doing to add them. Alright. Woo! So, 2 minus 4.
we don't have to do that one.
2, so that is.
Misty, we don't need to do on the test corrections the first one that everyone got wrong, right?
No, you do.
Oh, we do?
That's an AP question. You guys got to figure it
But you
out.
said we were going to talk about it.
What do you mean you don't know how to do it?
We will at some point.
You don't either. You got it wrong too.
No, I already know, like, yeah, but I figured out I did wrong.
Okay.
Okay, exactly. That's what everyone's aiming to do. Kiddos, how'd you think about the derivative of a piecewise?
So we just took the derivatives are different in different parts.
C and then 2x minus c, right?
You.
So we can go ahead and plug and chug, and that's how you guys hopefully were able to figure out that.
C equals. Oh, I was like, what?
Nope, it's not.
Yay, we're done!
Nope.
Nope.
No,
Because we read directions and we say, oh yeah. So we go and plug in.
Well, it's not C and D. You should find C plus D.
So we get 4 plus d is equal to 4 minus 4, which is just 0. So d is equal to -4. Now I'm right.
No,
No.
that's what I'm doing.
Because what is 2 minus 4?
That one.
Dun, 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 dun.
Alright, so
Okay.
are we doing FRQ?
Yep, let's pause. You guys want to do some work on FRQs? Play with number 1. You probably won't get to number 2. Using your calculator, 2016. What's due on Monday?
Yes.
DEF, questions on corrections, and then FRQ 1 and 2.
Hey, number 1.
Wow, that's a lot of homework this week, Steve.
Why, did you do ABC?
I did do it.
Oh.
I wasn't here doing it. You were over there.
I was hoping you would, because I would be able to talk about it.
So then it's, what is it, DEF?
DEF 1 and 2, but hopefully you can get through most of 1 right now.
I don't have a calc.
And then come with questions on corrections. Corrections are due by the end of the day Monday. I'll probably still take them on Tuesday. That's the one that you can kind of fudge on a little bit if you need to. Does that make sense?
Yes.
Welcome.